Hello and welcome to this video for Electropages. Today we're here at PCIM in Nuremberg and I'm joined by my very good friend Llew from Navitas.
Hi, nice to see you again.
Absolutely. Now last year we saw some pretty cool stuff with data centers and the GaN and SiC solutions that you guys were developing. But you've got some more interesting stuff coming out today, haven't you? So could you just quickly go through what's changed since last year?
Yeah, so since last year we released the bi-directional switch. It's a GaN switch. We're the first ones to do it at 650 volts.
This is the one that you couldn't talk much about, wasn't it?
This was under wraps the last time we talked, but now it's released. It's the first production release. It's a big deal, because it enables like single stage conversion from traditional two stages. So what that means is you can eliminate the DC link and the PFC inductors, and you go straight from a two-stage conversion to a single stage conversion. So that really reduces costs, keeps things simple, and improves reliability.
Fantastic.
So what we have here, we're focused really with our GaN BDS on solar microinverters. And here you can see this is an N-phase IQ8. This uses super junction MOSFETs. Here you can see the four 650 volt super junction MOSFETs and a 400 volt MOSFETs here. Now, the new IQ9, and N-phase has done a keynote speech this morning, and they're showing they're using now this bi-directional solution, which reduces the part count on the IQ8 by 4 down to 2. Now the switching frequency, because they've gone to GaN now, it's a higher switching frequency. They've doubled the switching frequency, right?
Yeah.
Which means they reduce the magnetics, so you can improve the efficiency and also the power density. So this is about 385 watts of volt-hour. This is going to 550.
And I think that's a really key distinction here, which is that even though they are the same size units, but it's not the size that we're gaining in this design. It's the fact that you've basically effectively doubled the power that it can.
Yeah, you can double the power, exactly. So these panels now going from 400 watts to 600 watts.
Yeah.
You can have the less amount of inverters for the larger panel size.
And there's one thing I've noticed as well. Now, correct me if I'm wrong, but you've gone from 4 switches to effectively 2 switches.
Right.
Would you say it would be right? Is it right to assume that effectively makes it more reliable in the sense that you've got less points of failure?
Yeah, but that's true. It's a monolithic design, so it's true. With the 4 switches, you have to have manufacturing issues such as voiding underneath the packages, or just general reliability and lifetime situations. Because one of these solar inverters, they go back on the back of a panel. These have to last 20 years.
Yeah.
So they have a 20-year guarantee from N-phase, but realistically, it's got to be 30 years if not. So
right, great question. So what application are these used in then?
So these are microinverters. They go on the back of a solar panel.
Yeah.
So instead of like a centralized one where you have, or a string where you have several connected to one big inverter, these are microinverters.
So every single panel has its own little one, and that way, and I'm guessing that kind of helps with things like energy saving, because I'm guessing if you have a large string of them, you're going to have huge currents going through wires, which is a lot of losses. You've got to carry it from a great distance, whereas here, you're localizing that conversion.
Yeah, exactly. So this is more for residential, light commercial situations where you want a modular design. And so, they both have their places in the market. This is ideally for that.
Now, obviously, the SiC design is it's double the power, and you've half the number of chips.
Yeah.
In terms of like the economic aspect of that design, how is it fair when you switch over as an engineer to SiC at the moment?
To switch over to BDS?
Yeah.
Yeah, so now BDS is a different type of device, right?
Right.
It and I can show you on that sheet, but maybe you can see it better, but it has 2 gates. So it does need to be driven slightly differently. You block the voltage in both directions, but you allow current to flow in both directions. So that's why when we say a bi-directional switch, the current can flow in both directions.
Now, just to be clear, this older design is also bi-directional, but the difference is that you've managed to effectively take advantage of your bi-directional chip, so you can effectively half the number of devices that you need.
Exactly, yeah. That's the idea, yeah. So what the GaN provides, obviously it's a very fast switch, so you can go to these higher switching frequencies, which enables smaller magnetics or higher power densities in the same size, like what you see here.
I've just realized I made a big mistake. I didn't realize it was, I thought it was SiC, not GaN. Oh, that's interesting.
It's GaN, yeah.
Oh, it's GaN. Oh, brilliant.
Yeah.
So in terms of like the design itself, would you say that over the past year, the technology that GaN is continuing to get better, especially with what you guys are developing?
Yeah. So as GaN matures, you can see obviously from a manufacturing point of view, yield point of view, but also excuse me, feature and functionality. So what Navitas does is we bring integration into the GaN devices. So what we're doing is bringing a more feature-rich set of features and protection features, which we can see in our other parts like our GaNSafe, which has short circuit capability. And with this one, for example, the magic in the bidirectional switch is the active substrate clamp. So when you're switching between the different states, you need to pull down the lowest source node to the substrate, because that reduces any drift of RDS on. So this is a very difficult challenge to do. It's an IC. It's monolithically integrated on the GaN chip. Because we're an IC, company, we figured this out first, and we have the best reliability and best performance.
A quick question about bidirectional switches in general. So I understand that in things like vehicles, you need them so that you can charge and discharge from the using the same sort of switch system, so you can push power back into a house if you want to do.
Right.
But when it comes to solar installations, for example, I thought it would be one way. So power comes out of the panel, you put it into something, and then you turn it into a sine wave, stick it into your house.
Right.
Why is it bidirectional?
So for this example, it's not bidirectional. This is just a different way of doing the topology.
Oh, so you're taking advantage of the fact that the switch is bidirectional, and as a result, you can then chuck two of those transistors.
Yeah, so for this example,
right.
It's called the cycloinverter topology. But if you're looking at like an onboard charger for an electric vehicle, this is where you go from a two-stage to a single stage, and you can do energy flow vehicle to grid to vehicle.
Would that mean you would only need the one device?
Well, you have 3 phases, so...
Okay, so 3, but one per phase, effectively.
Yeah,
that makes sense.
So yeah, so EV is a big market for this. We're launching this now at 50 milliohms and 100 milliohms, but there's a roadmap, obviously, for lower RDS on parts.
Now, speaking of automotive, I hear that you've got some parts that are now automotive grade. Is that correct?
That is correct. We have our GaNSafe, which are 650 volt devices, high power, and they have just been Q100 and Q101.
Excellent.
Because it is a IC, it's a Q100 qualification, but also just to give peace of mind, we've just tested the power hemp as well, the FET stage, that's Q101.
Yep.
So we give it both, all our customers like reassurance that both sides of the device work perfectly.
And sort of going into the next few years, what markets are you personally sort of looking forward to that will adopt things like these bidirectional GaN switches?
Yeah, so bidirectional solar inverters is a key one. That's going to really take off. Obviously electric, anything what needs single stage conversion, which is a multitude of different applications. Motor drive could be one, matrix converters, where you take it straight off the AC wave, and then you convert it straight into the motor drive phases. That could be huge.
And so that would also be considered industrial as well, wouldn't it? So anything like motor controllers, that kind of thing.
Anything, but it is a game-changing technology.
If it needs power, it's going to use GaN, effectively.
Yeah, we could say that.
Fantastic. Now, just before we wrap this video up, I've got one more question for you. For the people who are watching this video, if they want to get involved with your new bidirectional GaN switches that you can finally announce, what would you recommend that they do?
So we have all the data sheets on our website. Yep. We have evaluation boards, which has our ISOFAST as well. We have an isolated control gate driver with a bidirectional. This is an evaluation board. The user guide is on our website. And yeah, if you want some samples, if you want to know more information, please contact the site, www.navitassemi.com.
Fantastic. Thank you so much for being here today.
Cheers as always. Thank you.
Thank you.